hello. So I'm Daniel. Today I'm going to talk to you about the MySQL protocol. So I'm working for PingCAP, which you heard about. We make a product called TidyB. It's a MySQL compatible database. And before this, I was working as a DBA in a large e-commerce site where I was managing like thousands and thousands of servers in large replication chains with MySQL. So I've seen some MySQL issues and protocol issues, etc. I've been contributing to both MySQL, Wireshark, and various MySQL connectors and whatnot. So what are we talking about exactly here? It's a network protocol that is used to send queries from applications to a MySQL server and receive result sets. So that's the basic thing that the protocol does. Of course, there's much more to it, but that's the basics of it. The server side doesn't have to be MySQL. It could be MariaDB, TidyB, ProxySQL, because ProxySQL implements this as their management protocol, so to say. It's the classic protocol that pretty much everyone is using. There's a new protocol called X protocol that some of the Oracle products are using, but not all the products. And other than with MySQL, it's not used much. So the classic protocol is normally used on port 3306. So there are a couple of reasons why you might want to look at the protocol. The first thing is troubleshooting. If something goes wrong, you might want to look at the protocol traces to see what's going on, because it might be the client that's the issue, it might be the server that's the issue, you might be doing something wrong. So there are connection issues, protocol issues. For example, if you run a MySQL client and you type in some queries and you have some comments, by default, the MySQL query gets stripped. So all the comments get stripped out before it's sent to the server. So if you're like, why isn't like my query hints not being used by the server? That's because the server never received them. So that's something you might see on the network.
Daniel, your slide is advancing here. Do you know why? Did we disconnect again?
I don't know.
I don't know why it's not advancing. Can you try and share it again? Sorry.
Okay.
Yes. Now maybe. Thank you.
All right. Another thing you can do with protocol dumps is to actually do query extraction. So you might want to have like an existing application where you want to know what queries it's actually sending to the server. That might be used for like migrations and other things. Also, optimization is one of the things you can do, because you might want to see like why there are like many back and forths between the client and the server. And if you look at the protocol, it might become clear about why that's happening. You can also like write your own proxy. That might be useful in some cases. So that's also a place where it's really useful to look at the protocol. So the basics of the MySQL protocol is what's shown on the screen. So in green, you have your applications in different programming languages. Then there's usually like a database driver, like connector J. That's doing the MySQL network protocol. That's on top of the TCP/IP usually. Many of the connectors actually use the same C library. So they're built on top of the C library that the MySQL offers. So if you compare the MySQL protocol with the HTTP protocol that most people might be familiar with, is that the HTTP protocol is text-based, MySQL protocol is binary. HTTP has short connections. MySQL has like long-running connections for hours, maybe even days. HTTP does non-TLS on a different port than TLS, like port 80 and port 443. With MySQL, everything is on the same port, so that's also a big difference. So let's actually look at the protocol. The first thing that the protocol starts with is the server greeting. This is what you get if you just connect to the server, and the server responds with the server greeting. This is on port 3306, and it looks like this. So here you can see like many things about the server greeting. You can see like a protocol version, protocol 10. Well, basically there are two protocol versions, version 9 and version 10. And version 10 has been used for like many years. So basically the protocol version doesn't really matter. That's not what you should be interested in. You also see like many other things here, like the authentication plugin, which is just only a suggestion. But it did cause like many issues with both TidyB and other like open source databases, where things were just mismatching between what the MySQL client was expecting and what the server was sending. These slides are made with Wireshark. So all the things here is just dumping network traffic, loading it into Wireshark, and looking into what's actually going on. So after that, the client wants to do a client login. So this is what the client sends in the response to the server greeting. It might be a switch to TLS, because one of the things that's in the protocol is that there are client flags. There are server flags and client flags, and both are just feature flags that are either set or not set. And with TLS, if the TLS flag is set by both the client and the server, all the other parts of the server greeting and client login are pretty much ignored, and it just switches to TLS, and then the client will send another client login with the actual data, like the password and whatnot. After the client login, authentication methods happen. There are multiple authentication methods, so any of those can be chosen by both the client and the server. And after the authentication, the server either gives like an OK, or it gives an error back about why the authentication failed. So this is one of those client login packets. You can see that it has a username, root, but it also has like connection attributes. Connection attributes are really useful things to work with, because then on the server side, you can like see what client library versions are being used. You can see like why, what the purpose of a certain connection is. So for example, here you can see that it's a libMySQL version 8032. And when the program is MySQL, so you know it's like just someone doing interactive work, and it's not any like PHP application, for example. So that's quite useful. Here you can see on the MySQL server side what the client attributes look like. And here you can also see like the OS user on the client side of the connection. So the capabilities I was talking about earlier, this is what they look like. They're just a big list of them with all kinds of different flags. So that's what's used instead of a version of the protocol. So if there's new functionality, basically they add a feature flag for it, and a client and a server can just advertise the features. Another thing that's happening is that the features are based on the configuration. So if on the client side, you might say like, well, I want to use protocol compression, then it will switch on the right client flag in the client hello packet. So the client flags are really important, and with Wireshark that actually gives a problem, because if you start to dump the traffic just after the client login, then, well, Wireshark doesn't know what feature flags were set, And it basically has to guess how to decode things. So if you're dumping traffic, make sure you include the server hello and the client login packet, because otherwise decoding later packets might be difficult. So let's look into authentication. There are a few different authentication methods. The well-known MySQL old password, which is kind of insecure. There's the MySQL native password, what most people are using probably. There's a SHA-256 password, which is kind of deprecated. Caching SHA-2, that's the new kit on the block, which is default for MySQL 8. And there's a MySQL clear password, which is kind of useful with like external authentication plugins. So basically, this is what it looks like with the caching SHA-2 password. You have a server greeting which says like, well, my default is caching SHA-2 password. A client might be logging in and saying like, well, I want to log in with a native password, please. And then the server might say like, well, let's switch the authentication method and let's switch to caching SHA-2 password. And then the client might go like, yeah, okay, and here's some authentication data. And then the server might say like, okay, this is okay. I'm allowing access with a fast authentication success. The caching SHA-2 password does caching. And the caching bit, if that works, then you get like a fast success. If the caching part doesn't work, you might need some extra round trips. And you can see some of these things here as they look in Wireshark with authentication switch request and some of the authentication data that might be sent by the client. So in the previous slide, you can see that the server said the default is the caching SHA-2 password. And then the client logged in with the native password, and then you have to do like the back and forth. This is not always the case, but only in like certain configurations where the client and the server are not using the same defaults. So one of the things to influence the defaults is like with the default out option for the MySQL client. And many programming languages, it's not used very much. But that's one way to set the client, the authentication method on the client. Then on the server, there's the default. And for every individual user, there's the actual plugin, and that's used for the hashing of the password of that specific user. So that all three might be different authentication methods. But in the end, the method that needs to be used, that's the one that's set for that specific user. Native password is a lot easier. It's just basically the server sending some random data, the client doing some nifty things with that and sending back basically an encrypted version of that hash. It's based on SHA-1. SHA-1 is not really safe anymore. This method is not really safe anymore. But one of the specific features that this gives you is that it's sort of a safe way to like do authentication over an insecure channel. So if you're not using TLS, this kind of works. For the caching SHA-2 password, other methods are needed to actually make sure that the password is sent in a secure way to the server. So the secure connection can either be like a TLS connection, which is the easiest and best way of doing this. But caching SHA-2 has a specific option to also have like an RSA public-private key pair, which adds some like extra overhead and difficulties with managing that. But that's one of the options they have. And the other option is to have like a Unix socket, which is also considered secure. So this is another like Wireshark dump about using caching SHA-2. You can actually see that there's like a stream index in one of the columns. So there are two conversations here. The first conversation, you can see it like it's doing a login. Then it gets a perform full authentication option. So then it needs to request a public key because it's over an insecure channel. It gets the public key sent to the client. Then the client responds with like the encrypted password. And then the server says, well, it's okay. And then some more stuff happens and it quits. The second time, you can see it gets a fast authentication success because the credentials have been cached. And then the extra round trip is not needed. And let's go to the queries and result sets. So basically how it works is the client sends a command and the server responds to the command. And the response can either be like an OK or an error or a result set. Some of the common commands that can be sent are com_quit, com_statistics, com_ping, com_query. And there are a few things like com_refresh that are being replaced with an actual SQL statement. So this is what one of those queries can look like. This is just a simple create table statement. And you can see that like the command is the query command, and then the actual statement, well, is the statement. The query attributes are just optional, and for this matter can be ignored. And then this is what the response might look like. So this is an OK response on like a create table statement. So basically it says, well, it's an OK, and it gives some information about the server status. And here it gives you information about auto commit that is set, and it gives you 0 warnings and 0 rows affected.
One question.
Yeah.
Is there any possibility that the server side can piggyback some extra information in the OK response?
Yes. Yeah. There is some options for that, like session tracking. I will get to some of that. I think I included some stuff of that in this presentation.
I know because the arrow, we can definitely return some, customize the error message back to the server, but I'm not sure the OK response can have the extra.
Yeah, I think it can. So this is what an error might look like. So you get a packet length, a packet number, which is like something that every MySQL packet has. Then you get the response code, an error code, SQL state, and error message. Quite simple. So let's do a different statement. This statement is just a table T1, which is basically the same as like a select star from T1. And then we might get back something that looks like this. So you can see like here what the output is of the table T1. So we have 2 columns, 1 row, and you can see there's 1 column count, which is 2. There's a field packet for like the first column, a field packet describing the second column, and then there's 1 row packet describing this 1 row, and then there's OK to just say like, well, these were all the rows that I was going to send.
This is one response. It's all included in one response.
Yes. So if there would be like 2 rows, you would see like 2 row packets. This is what they look in slightly more detail. Yes. So the field packet for the second field on the bottom left has a length of 1020. So at 1020. And that's because of Unicode. Because like 4-byte Unicode, then, well, your length might be different than what you might expect for like a column like that.
Yeah, but according to the response, the last packet, the OK response here, I don't see any possibility that can add some extra information in this layout.
Yeah, not in this layout, but depending on like the flags that are set, there might be some options to have some more information.
Which flag?
So it would be a flag in the client login packet and in the server packet that set like an option for session tracking. Because there are some session tracking options to include GTIDs in various places. So let's do something else, a load data in file, because that's what many people use. So you do a load data in file of a CSV file to load something. And let's do it twice. And the second time you can see that it gives you 2 warnings. And it actually like shows you 2 warnings. So this is the first load data in file. And what then the server sends to the client is like, well, I want to do loading of this file. Please send me this file. So the client sends the statement to the server says to the client, please give me this file, and then the client responds with the actual file. So this is what the actual file looks like in Wireshark. You can see that it's actually looking like dissecting the actual file that's being sent. And you can export the file that was sent from the network traffic if you want. And it shows you the payload, and the payload is basically like test 2, test 3, etc.
What if the payload is super huge, like 1 GB?
So the max allowed packet size, MySQL will like limit that. So you can go to like probably close to 1 GB, but that's pretty much where it stops.
So MySQL cannot split the file into multiple packets?
No, it doesn't split the file into multiple packets. If you're doing inserts and other stuff, there are a few options to split things in multiple packets. But another fun thing here is that here's the response to the other load data in file statement the second time, where you can actually see it skipped 2 records and it had 2 warnings. The funny thing there is that it's not always matching the warning count in the packet. So this warning count is sent as an integer, like a 2-byte integer. And the message that you see here is just text. It's just encoded text. So sometimes in the encoded text, you will see a really large number that needs more than 2 bytes to store. And then, well, it can put that in like the warning field. So you might get like 2 different warnings in the same, in the output of the same statement.
So is there a situation that you have warning, but the statement is still executed successfully?
Yeah, so with a warning by default, it has been executed. It just gives you a warning, and it might have ignored things, might not have ignored things. That's up to the server.
So that means I can piggyback some information using the warning message, right?
Yeah, you can put other things in the message part. I'm not sure that's the smartest thing to do, but yeah, it's possible.
Yeah. I want to implement the feature that the server side can return the execution time for the query. That would be very useful.
Okay,
Yeah.
we should look into that.
But that warning is like duplicated entry.
Yeah.
That's more like error.
Yeah, so what we did was to do the load data in file, do it again, and then the second time it gave some warnings, and then we do show warnings, and this is what you get from show warnings. It basically just looks like a SQL result set because it had like a column count and a field packet and a row packet, and here it has just like the text as one of the columns. So here we actually have some extra information in the OK packet. It's a session tracking data. So here I think it has, it has the current schema tracker. So here you can see that the schema that's now being used is test. So this is one of the ways that you can embed more information in the OK packet, which saves you a round trip of just going back to the server and asking for some extra information.
But then that requires the client to specify renewed session checking feature open.
Not sure, might be. How am I doing time-wise? Okay.
No, not too bad.
So for replication, let's have a quick look in replication, because that's also using the same MySQL protocol. So basically, there are a few steps. The first step is to register a replica, then to actually dump information based on like a GTID or a position. And then you have the binlog events in that stream. So this is what the client hello looks from the like a MySQL binlog command that can do can fetch the replication stream. And here you can see in the query attributes that its MySQL binlog is a binary log listener. So you can see that the connection attributes are really useful. Then you can see that it's registering the replica with a bit of information related to like where to start the replication from. And depending on what you're using, you might get some GTID information or not. Here you can see a few binlog events that Wireshark can actually decode.
2 years back, that password that was like log, did that also go to the binlog?
Where did you see the password?
Back, or was it not binlog? So here, here, yeah.
So the password here is not really the password. It's just authentication data, and it's up to the authentication method to actually make something out of that. If you use the client, the clear text plugin, it will be the actual password. Yeah, so here are some of the binlog events that can be decoded by Wireshark. It's not decoding the actual payload of the event, but just only the metadata. So here you can see that it's doing a heartbeat event of the binlog stream, which can actually be quite useful because sometimes there are like bugs around the heartbeats that are not sent or sent too often. Statistics, also very nice. So in a MySQL client, if you do a /s or a status, you get some information. Some of that is actual queries and responses, but some of that is just sending a com statistics packet to the server. Then you get back some statistics. So on the left, you can see that it's sending the command for the statistics. And this is what the response might look like. And one of the interesting things here is you can see that the response is basically only a message. That's all it is, just one line with a lot of information. If you look at the output here on the bottom, it almost looks identical. But that's where the catch is. So here it starts with threads, and here it starts with uptime. So the MySQL client expects there to be uptime and with a number afterwards, and then uses that to actually fill in the uptime here. So it gets decoded from the message. So protocol-wise, you're free to send anything, but if it doesn't start with uptime and a number, you won't see the uptime here, and also your client will crash because they don't expect anything else there.
Is that a behavior for all MySQL clients?
Most. It's a client-specific implementation, so yeah. Compression. So there are two ways of actually doing compression in the MySQL protocol. It can be a zlib or a zstandard. And of course, there are feature flags for that. Then this is what a compressed packet looks like. So you have like a compressed packet length, a compressed packet number, and then the normal MySQL packet. And here you can see that the uncompressed length is 0, which means it's using the compressed packet protocol, but not actually compressing the packet, which it might not do if the compressed packet is longer than the uncompressed packet, or if the packet is less than 50 bytes, because then it doesn't bother compressing it. So this is for zlib. And here you can actually see that in Wireshark, it actually decompresses. And on the bottom, you can see the original bytes as it's sent over the network, and the bytes as was decoded or like uncompressed. So Wireshark knows how to uncompress the packet, so you can still look into the details of the packet. TLS, I think I said most of the things here already. But if you use like MySQL with like a specific older TLS version and an SSL cipher, it gets really easy to actually decode the TLS traffic by just giving it your key file, and then you just load in your traffic capture, and it can decode this. This doesn't work if you use like a Diffie-Hellman authentication method, but in many cases, this works quite well. And this is actually quite useful for troubleshooting, because there are like many cases where the MySQL handshake gives issues where like cipher suites are not matching or other issues are happening. And you can look into the TLS part of the whole conversation as well. So here you can, for example, see what the name is of that's on the certificate. Timeouts. So what can happen in MySQL if you have like a server-side timeout? The client can be disconnected, and then the server might send a message to the client to just try to inform the client about the reason of the timeout. And then you might get a message like this. It's a simple error packet with some text.
So you interrupted the execution, right? The timeout.
So this is more like the idle timeout. So if you just connect a client, and you wait a long time, then now the server tries to send like the reason for the timeout, because what it did in older MySQL versions was to just like close the network connection, and then you couldn't really distinct if it was a server wait timeout or just a network connection that failed. Yes, and here's some more information about session tracking. So here there's an OK packet with the actual GTID in there. And that's one of the capability flags that's being used for this. And especially the GTIDs with MySQL are very useful, because you might insert something on like a primary and then read something from a replica, but you want to make sure that it's a consistent read. So you want to supply the GTID that you got for the insertion of the data. Yeah, this is a fun one, deprecation of the EOF. So as I told you, there's quite a lot of extra information that can be in the OK packet. They also had a very similar looking EOF packet, and they just decided to merge the two because they didn't want to extend the EOF packet as well, which in theory is great, but there's a feature flag deciding if you want to use the old style EOF packet or not. So when you connect, you say like, well, give me the new style or the old style. The problem with this is that there's a query cache in MySQL, which now has been removed, luckily. But the problem with that is that they used to cache the result set and the result packet. So they were just sending the whole result packet to the client if the query's text was the same, which sounds fine, but they didn't take into account what the client sent in the client login message, if they want a new EOF behavior or the old one. So they just cached the very first packet that they got. And if you have clients with both the new and the old packet, it might send like the wrong protocol version to the client, and then things break. And this is one of the places where like looking into the network trace really helps. Because then you can see that like, well, if it works, then it has this flag, and otherwise it doesn't have this flag. Yeah. So this is what is copied from the MySQL documentation, the old EOF packet and the new OK packet. And then you can see that like the new OK packet has like all kinds of session tracking options. So OpenSSL is another interesting thing to look at. OpenSSL has MySQL support without even using any of the MySQL libraries. This is very useful when troubleshooting TLS connection issues, because MySQL will never directly start with TLS like the HTTPS does or like many other protocols. But OpenSSL knows how to like do the first client login packet with the TLS flag set to make sure that like it starts the TLS connection. Yes, so most of these slides were made with Wireshark, with the development version of Wireshark. Please test Wireshark and try to use it, because I think it's a very useful tool in your toolkit. Thank you.
I have one question.
Yes.
Just the one.
Yeah, does MySQL protocol support the pipeline style on the network part? Because I can see all the conversation between client and the service, request, response.
Yes.
Can we batch just like Redis did, batch a bunch of requests and send to the client, send to the server, and the server will batch return all the results.
So
Can you summarize the question?
Yeah. So the question is like, is there support for pipelining in the protocol? And I think the pipelining thing was one of the reasons why they started the new X protocol. So in X protocol, it's gRPC based. They have pipelining, that all works. But in the current protocol, that doesn't really work. One of the options there is to just have more connections open, and yeah, not great. Any other questions? Okay, thanks.
Okay, awesome. So welcome everyone. So this is not a talk, this is a tale. It's called A Legacy App Enters a Serverless Bar. That's way later in the story. Let's start from the beginning. Once upon a time, there was an application called Bob. It was during spring 2010. And speaking of spring, it was a Spring 3.0 application. Look how cute he is. So cute. And Bob was working for a really particular company. And it's pretty easy because here, it's the first time I do this talk in the Netherlands. Because usually I ask, do you know what stroopwafel is? Otherwise you are missing the best part of your life. And actually I got one today at KubeCon and I kept it. So that's a stroopwafel. And Bob, he works for a company, the Stroop app, where you can, it's a SaaS company, stroopwafel as a service. Okay? People can order stroopwafels. They can have 10 a week, 20 a week, 40 a week, and every week they will get delivered at their home stroopwafels. Okay? So it's a pretty simple app. Bob is dealing that. It's basically a CRUD app. Someone goes on the interface, creates an order, it goes to the database, and someone picks it up, the factory packs it up, makes it stroopwafels, and sends it, okay? And it's a huge success because stroopwafels, you know, and Bob is the absolute star of this company because of Bob, Stroopwafel is making a lot of money. He's the cash cow of the company, okay? So everything goes well. But, you know, in every story, but one day, he lives really near the boss. Bob lives in the server room, of course, and he hears the CEO say, "I want serverless. I want event-driven architecture." And Bob was thinking, "Hey, I don't really understand those words, and I have heard them sometimes, but I have no idea what it is. But my boss wants this." Suddenly, Bob realized that he was old. He was 13 years old. That's pretty old for an application, especially a Java application, okay? And worse, what he realized, that he was alone. All the developers that were maintaining him left the company. So Bob was just a jar running in production. And no one wanted to touch him anymore. Even if he was still the cash cow. He was feeling a bit like, you know, when you play Jenga tower, after 20 turns, it's at the moment it's gonna collapse or not, okay? That was how Bob was feeling right now. But Bob is resilient. He's using pretty good Spring libraries for that. And he decided to go on a quest to say, hey, I love my company. Maybe there are some solutions. Maybe I can help grab some info. And maybe even I can still be in the picture. Okay, so let me go on a quest. And he goes in the magic forest because they all live in magic forest. Okay, obviously like a bit like Efteling. And the first person you want to meet is the database. The database, they're working together for 13 years. She is Bob's best friend. You can ask her anything. And he arrives, and she's doing some complicated select stuff, select from GS order, and Bob says, Maria, can I interrupt you? Maria is a Postgres database. Her parents had a lot of humor. She's Bob's best friend. And she says, of course, Bob, we are best friends. Please join my table, said Maria the database. And tell me what is happening. So Bob says, yeah, he tells the whole story about the boss yelling about event-driven architecture and serverless. And Maria, she says, I know, I heard it. And Bobby said, but what is the problem right now? He wants event-driven architecture. What does it mean? Are we event-driven right now? She says, no, Bob, we are not. We are not. Come into my console. I show you how it works right now. Okay? So here we are in Maria. And she says, look, we can see here all the orders that has been processed, okay? And every morning someone comes into my console and he prints out the latest orders. So we are the 19th, so let me do this, for instance. Oh, no worries, of course. Someone do that, print it out, and goes to the factory and say, okay, today we have those orders to process. And that's not possible anymore. We should be able to detect at the moment that someone places an order, that the factory is triggered to adapt its production, okay? And I know, Bob, you can change. We cannot refactor you anymore. But I have a solution for you. And I have to go back to my slides. We are here. Please go in the forest, and you have to look for a wizard. A young wizard. He's called Debezium. He has some magic powers, and he might be able to help you. Give me your map, and let me do an update. That's the place where you need to go. Okay, so Bob goes on the quest of finding Debezium, the young wizard. After hours of walking, he finally met Debezium. And Bob says, "Hey, sorry, but are you Debezium?" Debezium is doing some weird stuff. He says, "Yes, my friend, I'm Debezium." Tell me what your problem is. So Bob again tells a whole story about the boss not happy and not being even driven, and they cannot change anymore. Debezium says, "I think I can help you. I have one magic power. And you know what I can do? I can listen to any database change. I can capture any change on the database. And since you're working with Maria, I could listen to the changes of Maria. And then I have all this data." And Bob is interested, but he says, "That's pretty cool, but what do you do with this data once you get it?" "Oh, really good question, Bob. I put all this data in a magic river called Kafka. Give me your map. I marked the point where you can find this river. Go to this river, talk with her. She will tell you everything about streaming data." Okay, so again, an update, and Bob continues his quest. And he finally finds a river, and he's a bit shy. He never talked to a river. And he says, "Excuse me, river, are you Kafka?" And the river replies, "Yes, my friend, I'm the magic river. My magic power is you give me any data and I can make it instantly available for anyone. So if there's a change in the database, you put it in my river and someone else can immediately take this change and do something with it." Wow, Bob is really interested. He say, that's pretty much event-driven. Kafka say, "Yes, that's so cool. I want to try it out. I think Debezium will be able to help me." Yeah, sure. Go to this watermill, which is called the Kafka Connect house. You will find Debezium there. He's waiting for you, and he will set that up for you. Okay? And then I will come back to me because I need to explain you other stuff about Kafka. Okay. So he goes to the watermill, and Debezium say, "Hey, you're there, Bob. Cool. Demo time." So here we really go in demo time. Okay, Bob. So of course we are using Aiven to manage our data services infrastructure. And look at this. That's me here. Maria, I'm here. I'm running. We have a Kafka here running as well. Cool. And well, the watermill where we are right now, the Kafka Connect, is also running. And that's where the magic will happen. So let's go to this service. And Kafka Connect, we will be able to create a connector, you, Debezium, and you will be able to listen to a specific database, Maria. Okay, so let's do it. So let's click on connectors, and let's create a new connector. You have different kinds of connectors. You have sync connectors. In our case, it's not a sync connector, but it's a source connector. Okay, so let's go to the sources and look at all those options available by Aiven also. And look here, that's me, Debezium. Okay, so click on Get Started, even if it's a bit confusing as a button. But okay, So what do we need to do here? Where are all my, I need to configure a few things. So let's call it, well, it's live coding, so live coding, connector name, whatever. Here we can keep the defaults. The really important stuff here is Postgres. I need you to tell me the details about the database I need to listen to, okay? And I need to give it a namespace so I can do whatever I want, live coding, okay? And then I need host name. So let me go here, let me grab the host, and let me put it here. I need the port, okay? Let's put it here. The user is AVN admin, and the password, let me grab it here. We are almost done, Bob, don't worry. Okay, and database is orders. I need a specific plugin called page output, okay? And let me think, really, is that all I need? I think so. Here I have a recap. So pretend you're not seeing the password here. And let me create the connector. Yeah, I will tear down after if I think about it. So. Oh, the database hostname error while validating code. What? No. No. It will. It's no more. The demo goes. Usually, I burn Windows Vista CD-ROM in the morning to please the demo gods, but I was out of CD-ROMs, so Vista, yeah. Millennium works best. But let me try it again. I think he cannot make the connection with the database. I didn't.
Maybe you shut it down.
If it's shut down, it should be, no, it's running. Okay, let me think. Let me sit, because I think better when I'm sitting. What is not working? Here, well, I did it thousands of times, of course. Error, host name.
Oh, the port.
The port? No, the port is there. The port is there.
It's the wrong one. You put the wrong one.
I put a wrong port?
Yeah.
Really? No.
Yeah.
Oh, yeah.
Yeah.
Oh, you know what? It's probably, I did a copy paste, but probably I scrolled here. Okay, so.
Solved.
All solved.
Oh, we're not.
Yeah, all solved. It's all solved. Okay, thank you. Look. DBSM says, I'm up. Now, if you enter order in your app, it should come. I should be able to capture that and send that to the Kafka cluster, which is running here, okay? So if I go to this Kafka cluster and I look at all the topics, and there are quite a lot of topics, but live coding, public each order, that should be the topic where my changes come, okay? So Bob, let's create an order. So we create a new order. So here you see it's a Spring Boot app, live coding order. We take the stroop master offer, okay, because we like stroopwafels, and it's from today. Okay, so now I will hit save. It will go into the database. DBSM will detect the insert and grab that data change and send it to Kafka. Let's see if it works. Okay, so there we go, and let me go now here to this topic here, to the messages. Let me fetch the messages, and let me decode it. And the last one should be after, oh no, sorry, the first one. The first one should be live from, oh no, where it is? Where? ID. It was not there. Let me see. Live coding, publish age, it should be there because he has. Don't worry. Order. He grabbed all my orders. Demo gods are pretty funny today. Let me try it again. Let me create a new order. Come on, demo gods, be with me. Let's go for the medium. Maybe that was the issue. And let me save that. Okay, is there, come on. I don't know what I did wrong otherwise, but no, fetch messages. Decode, live come on, why are you doing this to me? You know what? Let me grab a small piece of.
Is that correct concept you're looking at?
I think it's so, because it's live coding, publish JH order. Yeah, it's the correct one. What might have, come on. No, totally not where I want to go. I want to go back here to my Kafka Connect, the watermill, the connectors. Okay. Oh, look. Ooh. The connector will be stopped. Why will you be stopped? Connection in it. I know. Because, sorry, Maria, she says, yeah, to make the magic happen, I'm using a special page where I write all my changes that I call the publication. And in the connector, you need to specify this publication. Okay, so let me go here. Let me edit that. I knew I was missing something. Publication. There we go. Go order publication. Publication. No typos. Okay. Let me save it. It should be better. Now, sorry again for that. But it's for Bob. You know we are doing. Bob is putting all his hope on us, so let's try again. This time, it's good. Good. We go for the small order, and we go for today, and we save it. There we go. I go back to my Kafka cluster, which is running here. I go to my topics. Cool. That is the one. I get my messages, fetch messages, and now 6 items. This time it's good. Okay, so yeah, it was my fault. It's never. We always blame the demo gods, but it's always between the computer and my hands. Anyway, Bob is super excited. He says, "Wow! We are event driven." But then he says, but now it's in Kafka, and who will pick that up? Who will do something about that? How do we connect the factory, the Strohwafel factory to that? And again, DBSM said, really good question, my friend Bob. Go back to the Kafka river. She will explain you what is next. So he goes back to the Kafka river. And he says, okay, now you have your data available, but what happens with this data? Kafka River says, well, someone needs to pick it up, okay? You see there, this person? His name is Karim. He's from the Quarkus dynasty. He's really reactive, really fast. He can capture really fast and process the data that is put in my river. Go talk with him. You will probably do a small demo and you will understand how it works. So Bob walks to Karim and he says, hey, Karim, can you show me how fast you are in capturing Kafka records? And Karim says, of course. Come into my IDE. And there we go in the IDE. So, sorry, I don't know if there are developers here, but it's pretty simple. Look, I got here one method and I listen to the incoming topic, okay? And I have here a Debian library, and I can have a deserializer for the change that came in, okay? And then I put that into a classic Pojo, and from there I can do whatever I want. Here I will do it with a log info, okay, launching the stroopwafel production. But in real life, we will do something, we will create the stroopwafels, okay? So let me launch myself, and I will show you how it works. Oh, that was funny. Let me start myself. So let me start myself. And of course, I've got some properties here to know which Kafka cluster I must listen, okay? So look at this. I'm waiting for the latest message. For now, there's nothing here. And if Bob, let's create a new order, and something should happen in my application. Okay, let's try this out. Okay, why not? Let's go for large, and I go for it. This state, and I save it. Again, it goes to the database. Debian picks it up, put it in Kafka River, my Quarkus app, which is running here. My Quarkus app should be, oh, yeah, I know. You know, Bob, you didn't tell me you changed the topic name. You should have warned me. Oh, sorry, Karim. Let me change that right now. Oh, yeah, that's not important. That's low. That is running locally. This for my store. So let's change the topic here. Let's do it again. Security is important. Okay. This time the topic. I'm a bit in stress. This time the topic is good. Okay, I go for Stroopmaster, and I go for today. There we go. So again, to the database, Debian captures it, puts it in the Kafka River, and look at this. And Karim picks it up, and he captured the change here, launching a stroopwafel for this time the topic is good with the offer Stroopmaster. Wow! Bob is so excited. He says, "We are event driven." Yes, we are, and we are officially event driven. So Bob is really relieved, but suddenly he says, "But Karim, are we serverless?" And Karim looks at Bob. He says, "You know, Bob, I'm sorry to tell you that, but no, we're not serverless yet." And Bobby says, "But I don't even know what it means to be serverless." Well, serverless means a lot of things. I could do a whole other story about it, but basically, it's even more abstraction. And when you are not needed, when Karim is not needed, when it's Sunday, the factory is not running on Sunday, he should not be running, okay? To preserve some resources. And only when data arrives in the Kafka River, it should wake up Karim. And then you will be serverless. Ah, okay, I see. But you know what? I have some good news for you. I know someone that can help you for that. Okay, but we have to travel together. It's a really long trip. Oh yeah, look, Bob was, oh, I will help you. Don't worry. We need to go to Kubernetes City. It's on the cloud native ocean there somewhere. Come with me, and there we will find someone that can help you. So they walk for days and days, and they arrive in the harbor where all the containers are managed. And he says, we need to find the serverless bar. And there you will find a person that can help you. A legacy app enters a serverless bar. No one is there. It's a serverless bar. Say, hello, is there anyone that can help me? And you hear someone saying, yes, I can help you, but please come outside behind the bar, and I can explain you a bit who I am. I'm Ken. I'm from the Knative family. Karim told me your issue. So I'm from the Knative family, and my magic power is I can take whatever workload, I just need a pod, and I can make it serverless. I don't care about the technology. It can even be a pod running COBOL. Can make it serverless. Wow, that's super cool, say Bob. But for that, I need to put Kareem into a container, okay? And we need to go into the cloud native ocean. He needs to go in the cloud. Don't worry. Go back to the water mill, and once we are in the cloud, give us a call, and I will give you some instructions. Okay? Exactly what I just said. So he goes back to the. Sorry, we are almost over. So he arrives at the water mill, and he calls Ken. He says, "Hey Ken, are you there?" And Ken answers, says, "Yeah, we just arrived in the cloud with Kareem. I give you this link. Just connect to that, and you should be able to see us." Okay. So he click on this link, and that is a Kubernetes server. Oh, and it's really funny with this resolution. Doesn't really matter. Okay, you should see Kareem here. Okay, he's sleeping right now. Oh, yeah, if you click on it, you can see it's auto-scale to 0. No resources are running, okay? And look, here you can see another component. That's me. Well, it's someone from my family. And that's a Kafka source. And my magic power is that I can listen to a topic, okay? And when a record arrives on this topic, I wake up this workload, passing the workload from the topic, from the record, to this application. Oh, that's cool. And did you have to refactor Kareem? Yes, I had to refactor a bit Kareem, but it was pretty easy. And it's Quarkus, it's really easy. And I will skip you where I show you the refactoring part because we're running a bit late. But anyway, I just need the Kafka source. I just need to be modified a little bit because, the topics has changed a lot and I won't make the mistake twice. So let me see. And Bob, he says, "What is that?" That's YAML, Bob, because Bob, he didn't know YAML, Wow, that's scary. Yes, it is. Believe me. But everyone is using that now. Okay. So here we just need to change that. Live coding. Okay, that's a topic we have. I save it. That should, he should restart. That will wake up probably Kareem because we are changing him a bit here. Yeah, that wakes up Kareem, but let's ignore that for now. He will go to sleep back in, I think I've set it to 15 seconds. So just the time for me to drink this water slowly. Mm-hmm. Okay, Kareem is back to sleep. Now we can make our final test. All you have to do, Bob, is enter an order, okay? You enter an order. It goes to Postgres, DBZM picks it up, puts it in Kafka. Knative Kafka source listens to the change and wakes up Kareem, which is running in a pod. Easy. Okay, let's go. So the final demo. Let's go for medium. Let's go for here. Save it. Let me go back quickly here and look. Instantly, Kareem is wake up. If I go here to the resources, I check the logs. I should see here that launching Strova for production for the final demo was offered medium. That's awesome. So that means that the factory can really adapt its production. And when there's nothing to be done, like now, well, it just can go back to sleep. Terminating, you go back to sleep, Okay, Bob, that's it. We are event-driven. We are serverless. Let me conclude. So it was time for Bob to go back home. But he was so happy. He made so many friends, and he had solutions for his boss. Bob told the boardroom about his quest and his new friends. He beat him all the adventures going to Kubernetes City. And everyone was really happy, and they said, okay, Bob, you can stay for a bit longer, okay, the time that we We won't decommission you right now. It's a happy ending in my story because someone told me, yeah, we should have just we would have shut Bob down, but no, it's a nice story. Bob, you can stay for a bit, and that's it. So I'm Sébastien Blanc. I'm a developer advocate at Aiven, and I wish you a nice evening. Thank you. Question?
Where did you get all the pictures?
Really good question. So I'm a really bad designer.
I was going to say, is that AI?
That is Midjourney. Midjourney with the challenge of keeping always with the prompt similar images. So I was using an old rusty robot in manga style, and more or less I could have always the same style. Yeah.
Yeah, I was like, how's you got all the images?
Yeah, really good prompts. That's the. Yes.
There's a question about DBZ.
Yes.
Can you maybe describe the kind of like project goals of DBZ a little bit more?
The project, how it.
Project goals of DBZ, is it meant to be just a connector between database to?
It's basically first of all, it's an open source project, of course. We haven't talked about DBZ after right now. No, was I the last one?
No,
We have to talk. Yeah, I think I saw it. But basically, it's a connector. It can read data changes from any databases. So here I show you that for Postgres, but there for MySQL for any. And by default, it sends it back to a Kafka cluster, but it could send it to whatever other. It could send it to a Pulsar probably, and how it works technically. I don't know exactly because I didn't build it. No. I should know it. I know the creator really well, Gunnar Morning. He's a friend. Yeah. Any source, yeah.
You can, for example, like MySQL, so you can read the log and send to the downstream, for example, log with HTML. Yeah, basically it's a bridge between different databases.
The filter you set up some point that you forgot first, but then you saved again. You remember? Was it like a topic or another topic? What to filter on? What was inside of the label then? Or something?
No, I didn't send any filter. I could have filter on one table, for instance.
Yeah.
Here I just put the database so it captures all the changes from all the tables.
So all events will go.
All events, so the deletes, if I was the good way of doing that, I focus it on one table and I say only on inserts, for instance. And other cool stuff with Postgres 15 now, when you create a publication, you can add a where clause. So you could say, if there's payments below 50 euros, for instance, then capture the data and send it. So you can do really business rules related stuff. That's pretty cool. Yeah.
For this setup, like Java, personally I don't work with Java a lot, but Java applications are pretty slow with getting up.
Well, not Quarkus.
No? See, that was my question. Like, don't you maybe always want to have one pod running with that scale of it?
Oh yeah. So here I'm using Quarkus still in JVM mode, but I could compile it to native, and then it started even faster than a Go app.
I challenge you on that one.
Oh yeah. It's going faster than but Knative, you can tell them, hey, always keep one pod hot running.
Yeah.
You can configure that. Okay, that's something. And if it's a Java app, once the GVM is warmed up, it's really performant. So you could say, hey, always keep 2 pods with a GVM mode warmed up. And in case of because Knative is really good at scaling up when there's a lot of requests, then spin up new pods. But yeah, you can configure that.
Yep.
Yes.
Why you had to copy paste host names, ports, and credentials, given it's all inside Aiven?
Oh, don't tell me. I know.
I
I told the product team. I told the engineers. Yeah, it should be more integrated. They're aware of that, but it should be more integrated.
Yeah, and then I guess like this follow-up question, when you're consuming from this Kafka stream and
Yeah.
your applications, what happens when you're consuming more than when you're putting up more than one consumer? Are you splitting this? Are you splitting the stream and probably in parallel automatically?
Oh, that's
Are you partitioning the topics?
Well, it depends. Now it's just one consumer group with one app. I'm not sure I get totally your question.
So like you showed us like audience coming from 0 to 1.
Oh yeah, sorry. Yeah.
And then how does it work when you're doing from 1 to 2 or
Okay. Basically, by default, it will start to scale to different pods if there are more than 100 concurrent requests coming in. That's the default of Knative. So if there are 200 direct records put in the topic, then it will scale to 2 pods. Yeah, that's it. For demo purposes, I could set it way lower, but basically that's the default. Default is 100, and then it starts scaling up.
on the consumer side?
On the consumer side, it's a pod. It's basically not a pod. Yeah. And it will create another pod that will join the consumer group. It will join the existing consumer group. Yeah?
Yeah, so this is going to be the last talk today. And my name is Kewei. I'm a data engineer at Bolt. And today I'm going to share some experience. We run data lake at Bolt and how we actually migrated our CDC with Debezium and changed the capture pipeline from Debezium to Thai CDC. And so the agenda is so we're going to introduce you a little bit about Bolt, what do we do, and then we're going to go on sharing some experiences of operating our data lake and our old architecture. This year we actually migrated to a new data lake architecture using so-called Lakehouse using Presto. And then I'm going to go on talking about CDC, like I'm going to answer some of the questions that you have, like what is CDC? I'm actually a Debezium contributor as well, and why we actually switched from Debezium. I love Debezium, but why we switched from Debezium to Thai CDC, and some of our future plans that we're going to do this year. So what is Bolt? Bolt is a tech company. We're the largest competitor of Uber in Europe and in Africa. So we have over 100 million customers. We're spread across Europe and Africa, over 45 countries. We have 3,000 employees. So this is our business verticals. We have ride hailing. That's the biggest vertical. We also have scooters. We have food delivery and boat drive, so you can rent a car on the street. And we also have a boat market where you can get fast grocery delivery. And so we're still hiring. We have lots of people from different nationalities, and our headquarters is in Tallinn, and that's where I'm working currently. So if you're interested after this talk, check out the jobs page. And so this is basically the architecture, a simplified version of our data lake architecture. And this is the old version, so we don't use this architecture anymore. And you can see we have lots of clusters of MySQL, and we use Debezium MySQL connector to do like real-time streaming of data from MySQL to Kafka. And once data is in Kafka, we have different usages. One usage is like Sébastien said, we have event-driven microservices. And for me, I'm part of the data engineering team, so my usage is not that. My usage is to put data into a data warehouse or data lake, because the queries that I would use to query MySQL is very different compared to queries that I would use to query analytical queries like aggregation, joins, using a like a data warehouse like Redshift. So basically, we want to sync data from Kafka to a data warehouse. And we use KSQL. It's an open source streaming framework. We use that to do some stream processing, like extracting JSON columns into different new columns, and doing some filtering, cleaning. And we have open source S3 sync connector. This is implemented by Confluent, which is the Kafka company. And then once data is synced on S3, we have a periodical batch job that actually load data from S3 to Redshift. And so there's some problems of this architecture. First of all, we have petabytes of data stored in Redshift, and it's a lot of data. And also, we have hundreds of thousands of analytical queries per day. And Redshift, at some point, is just not scalable for us anymore. At some point, we add like a double our cost, but the query performance is really limited. Query improvement is quite limited. I also tried RA3 node, which is the new generation node of Redshift, and AWS advertised it as like there could be a huge improvement of performance, but for us, it's not the case. And also, our 3 node at that time was too new for us, and there are some schedule scaling problems. And also, the data pipeline you see from this slide, there are lots of components. There are KSQL, S3 sync, and the batch job everywhere. And it's really hard for different domain teams to self-service to ingest the data they want. So they actually come to data engineering and they ask us to ingest their table. And so our team becomes a bottleneck. Yes. And also some teams, they use Spark. And using Spark, you read from Redshift is quite ineffective because you actually have to export data from Redshift onto S3. And this is quite time consuming. So this is our new architecture, and everything after Kafka has been changed. Everything before Kafka stays the same. So we use MySQL, Debezium, and Kafka, and then we basically give up Redshift because it's too expensive and it's too slow. And what we use is we use Spark streaming to consume data from Kafka. And we dump those data on S3 using a specific format called data lake. And I'll give you guys an intro about data lake, but it's it supports ACID transaction. It supports mutation pretty well. As you guys probably know, we have lots of updates, not just insert, append only, but updates in MySQL and TidyB. Same. So we want to find an easy way to do this, mutable data ingestion. So data is stored on S3 using data lake format, and we store metadata of tables like table columns and types in a service called Amazon Glue catalog. Yeah.
Do you store the final states in this data lake or the whole log of changes as well?
Good question. So data lake has a feature called snap, like a checkpoint. So you don't actually, you do store the whole logs, but it has compaction. At some point, it compacts all the log files into smaller ones, but it does have all the files that you need to read from the table to get data from.
I never looked at what happened a few years ago. Whether these changes or not, so we don't care.
So we have a retention period. So there's the vacuuming. So you can configure what's the retention of this kind of like a Bing log or transaction log. Typically, we set it to 1 week. Yeah. And the Presto. So Presto is basically the data warehouse at Facebook, and they open sourced it. So it's a query engine. It's a stateless. It doesn't have any data. So it reads data from a data source. It could be MySQL. It could be S3 in our case. It could be Kafka even. As long as you can represent the data into a table format, table and row format. So there are lots of benefits of this new architecture, but I listed the 3. The first one is the like format is really mutable friendly. Second is it helps basically change our team's kind of like dynamic structure a little bit. Our team is no longer the bottleneck of onboarding new data. Third one is Presto clusters. They're stateless, so you can actually scale them very almost unlimited. So you can just spin up new Presto clusters to have more query serving capacities. So what is Data Lake? It's open source. It's implemented by Databricks, the Spark company. And you can see on the left side, this is basically the layout in terms of like files and directories of one specific table. So you, the Parquet file is basically the data file. It stores the data itself. And there's a underscore data underscore log directory, and that stores the transaction log. And for example, here we have just one transaction of this table. This table is partitioned by created date, and that's a specific date. If you have two partitions, it will be two directories. And in this transaction log file, you can see it's a simplified version of the content of this file. So basically, it's the file path. It's the pointer to the Parquet data file. And the Parquet file just has the data. It has one row. And so what we do is imagine there's some, imagine this is a table we actually replicated from Debian, from MySQL or TiDB. And imagine there's a update of this row. The order status now is in progress. Maybe we'll update into something like finished or done. And what happens is this change data will be like streamed to Kafka. And once it's in Kafka, we use a Spark job to Spark streaming we basically run this line of code to ingest this row into S3. So what it does, so the existing data table is a variable. It's basically a pointer to the data lake table on S3, and we just rename it to target as it's the target table. And the data frame from Kafka, if you're familiar with Spark, will basically read any kind of data into a Spark data frame. And then we rename it to batch, and we merge it when the primary key, the ID, is equal. So that means, okay, this is the same row, and if it's matched, we basically updated it. And there's a condition to make the merge extra safe. So we make sure that the source Kafka offset should be larger than the target Kafka offset. And when there's no match of the ID, that means it's a new row. So we just insert it. And after running this statement, this is Spark API. After running this, we have this layout of the table. So we have a new file called data file called B Parquet, and we also have a new transaction log on S3. So data on S3, they are not mutable. So you gotta have to. You cannot. It's not a local disk, so you cannot actually open the file and do some append information and save it to the same file. You actually append a new file. You create a new file. So in this new transaction file, what you have is you actually you're removing the old Parquet file from the history of the transaction, and you add a new Parquet file, like b.parquet. And this new Parquet file, you have the new status, like finished, and you have a higher Kafka offset. So basically, it removes the old pointer to the old file, and it adds a new file. And self-service, so basically, this is what our domain teams, like when I say domain teams, like we have hundreds of different domain teams, like campaign teams, ride hailing, food delivery, and they would just add this configuration to our system, and the magic would happen automatically. Spark will pick it up, and it knows from which the sources is basically the Kafka topic, from which Kafka topic to consume the data from, and into which data lake table on S3 we want to ingest the data to. And we have unique key and the merge version column, which is used by the upsearch code we just saw earlier. We have partition column. So at Bolt, we usually partition tables by date. So we have each date, we have a new partition of the table. And we have columns as well. And with this architecture, it's a simplified version of our Presto clusters. We have quite a lot of clusters, and each dedicated to a specific domain team, and they do not actually have any impact over each other. Their query performance is independent of each other. And the majority of our queries are from Looker, which is a dashboard solution. We have we're a data-driven company. We have over 1,000 users querying Looker, which queries Presto on a daily basis. So yeah, if you guys are interested, you want to move your data warehouse to Presto at some point, there are some tips. So we have hundreds of nodes, Presto nodes. We actually didn't really have any expertise of Presto, so we use a SaaS provider called Ahana to start deploying Presto. And they've been very helpful. And last week, they were acquired by IBM. And also, if you want to deploy Presto, start with a large VPC because it has enough available IPs. What we did was mistake is at the beginning, we deployed into a very small VPC, and we had to redeploy the whole thing again in the newer VPC. And also some AZs, availability zones in some region, they don't have the same number of available EC2 instances for specific types. For example, we use our nodes for Graviton, and this specific node actually is missing. Maybe it has like 20% of this node compared to other AZs, and that's an interesting discovery. And so to speed up query latency for Presto OL Query Optimizer wants some specific stats from table like columns, cardinality. It helps the query optimizer to choose which table, if you join two tables, right, which table it should use as the hash map, and which other table used as the probing side. So it has to know the stats. So we run analyze table periodically, and the table stats is saved in Glue, in AWS Glue. And we also enable Hive connector cache because it would also speed up the query. It doesn't have to query the metadata every time there's a query. And we, because the volume of the queries, we actually hit the AWS Glue account limit. And so each day we're receiving, I think, hundreds of thousands of throttling errors when we call Glue API. And that was not good, but Presto has retries mechanism, but still, we actually increased the account level Glue API limit for that. And then it was all good. And also, Presto has a query log. What does it mean? It means like for each query, when it's done, we log the metadata of this query. So we know the runtime, we know the CPU memory consumption, we know which tables this query has queried, and which user actually sent this query, et cetera, et cetera. So this is very valuable for us to know, investigate the query patterns of different teams. And so database migration, prior to 2020, our debate team uses MySQL extensively, because our business growth and our data growth, it's just, at some point operational wise, it's becoming a pain for our debate team An example is adding a new column to a large table would actually take a week to do so. And moving a table from different clusters is also quite difficult, and resharding table is quite difficult. So I tried. Actually, we didn't really try TiDB at the beginning. We tried VTest, which is also a framework built on top of MySQL. It's used at YouTube, so it has a good scale. But it also supports MySQL protocol. So ideally, for a backend service, it's easy because we migrate from this MySQL protocol to the same MySQL protocol. So that's the ideal idea. But in the end, actually, it's proven that VTest operation is a little bit more difficult than or DB has expected. And also, VTest didn't really have a CDC solution, so there's no Debezium connector for VTest. And we actually dig very deep. We actually implemented a Debezium VTest connector, and we open sourced it. So now it's running under Debezium umbrella. And even though we didn't really go with VTest, but this connector survived. And it's used by other companies like for example, Stripe. So VTest is a no-go for us. And in the end, we decided to go with TiDB by PingCAP. So the POC was really successful. It turned out to be really scalable. The compression of TiKV is 3 times more efficient compared to MySQL. It supports ARM architecture, the Gravita instances, and it's open source. And we also bought the enterprise support, and so we actually work very close together with PingCAP. An example is TiCDC. Like when we were doing the POC, TiCDC was not mature enough, and I'll give you guys some examples in the next slides. But we worked with them, PingCAP, and thanks to them, actually, we developed. They helped and developed a new Avril CDC protocol, which actually works much better to move data from TiDB to Kafka. And so what is change data capture? So I think it is the same thing as what Sébastien shared earlier. Basically, if you insert a new row into a database, there's a CDC component, and it will just send the same data into another storage thing. Either it's another database, or in our case, it's Kafka. And this is over. I'm not a CDC TiCDC expert, but this is like an oversimplified version of a TiCDC architecture. You have a cluster of nodes in the TiCDC cluster, and each node runs a capture process. And there's one capture, which is the leader. And the leader takes the job of actually doing some centralized operations. For example, when you create a change feed, which is kind of like a command saying, I want to replicate this table into Kafka, for example. And this leader would actually split the tables into tasks and assign the task across the nodes in the cluster. And then data flows from TiDB to Kafka. And what if the TiCDC cluster restarts? How does it know where to restart? Where does it store the offset? And offset is stored in the PD. It's basically a metadata store. And so essentially what we do is we basically deprecated MySQL and Debezium, and we started to use TiDB and TiCDC to stream data into Kafka. And this is an example of how we should create a change feed so that TiCDC would know that which tables to stream from TiDB. So you can see we have a Kafka cluster URL here. We have schema registry, and we have filter, which is the rule. So here the filter says I would stream all the tables except the tables from the demo schema. I don't have demo, so The sync. So the sync basically says like, okay, I want to name the Kafka topic with this naming pattern. So we have the TiDB schema name and topic name in the Kafka topic name. And protocol is Avril because we've been using Avril for Debian as well, and Avril has a schema evolution support. So at the beginning, like pre 6.1 TiDB version, TiDC version, it was not really ideal. We found a lot of blocker bugs for us. For example, it doesn't support enum column. If you stream an enum column from TiDB to Kafka, instead of giving you a meaningful string, it gives you the index of the enum. And for us, we don't really know what 1 or 2 does means. It doesn't support text or long text. It doesn't support. You would lose position for timestamp, and it doesn't support JSON. And the one change feed you can only actually stream one table into one Kafka topic, and we would have to create thousands of change feeds for that, and it's not practical. And also from a self-service point of view, it's not practical. And so all this actually solved in version 6.1. That's what we are running, or CDC. The version that we're running at. And this is an example of the table, TiDB table. And if you use TiDC to stream it to Kafka, and this is like a JSON-fied version of the Avril format, you can see it's everything is fixed. And yeah, so there's another difficulty which has nothing to do with PingCAP. It's just the way migration works. When you use TiCDC to stream data into Kafka, actually, TiCDC and Debian, they have different Avril format. It's not 100% compatible. So we actually have to use another Kafka topic. So ideally, if we live in a simple world, we just ask Spark streaming, stop consuming from the Debian topic and switch to Kafka, the TiCDC Kafka topic, and that's it. And we tried it actually and didn't work. And why? Is because actually because this TiCDC Kafka topic is a newer topic, its Kafka offset is much lower than a Kafka topic that's been running for years. So Kafka offset is basically the global location index of each Kafka record. And so when we do the merge, we actually look at this Kafka offset as a version column, like which version of the same ID you want to take. And because it has a lower version value, the merge doesn't work. So we actually, instead of using Kafka offset, we started to use another technical column called last update, and it worked well. And so this year we have some plans included this year. First one is to improve data observability. It's an issue for us because we currently we only monitor, for example, ingestion lag. We know something's broken. This table freshness has been increasing into certain threshold, and we send alerts. But we lack visibility over, for example, the number of nows for a column, the mean max value statistics of certain column level. And this actually is bad because when we do migration from MySQL to TiDB, we need this observability to make sure that the data quality doesn't deteriorate, doesn't go bad. And the second one is a unified access management. So the new lakehouse architecture, it has another advantage, which is, for example, when you use Spark, you don't have to export data from a managed data warehouse. It's already there on S3. So we actually, our Spark use cases increased quite a lot. But Presto and Spark access management is completely different. So we're looking for a unified access management solution for both Presto and Spark. And data catalog, and so we want to have a data catalog this year. Or users, they complain about, okay, we have thousands of tables, but when some of the domain teams, they're actually building the same table without knowing that actually there's already a table that can serve them. So they want to have the capacity of search for tables and know what actually the table means and what each column of the table means, so that they can actually reuse the tables that maybe other teams has created. Yeah, that's pretty much it. Yeah.
Have you considered ditching the whole data capture and Kafka thing in favor of TIDBs like columnar tables based on TI Flash or their direct integration with Spark?
So you're talking about like why not use TiDB as a like an analytical?
As well, and they have direct integration with Spark as well. So,
yeah. Yeah.
Have you considered it?
Yeah. We knew this. Yeah, we knew this feature exists, but it was a bit too much for us to do 2 migrations at the same time. At that time, we didn't really decide whether we should go with TiDB or not. And so data engineering actually started to migrate away from Redshift, and we are eager to find a solution that can replace Redshift. So these 2 parallel works kind of like didn't really interfere with each other.
And another thing is that I would say he's going to TypeFlash. TypeFlash is a coordinator and separator for the role-based storing TiDB. If you have a very sometimes the analytics job you are not going to run on the original table. You sometimes need to do some ETL or application or point, something like that. So I would say if you only do some really lightweight analytical workload, using TypeFlash is okay. But I think for folks, their data analytics job is super complicated.
Yeah. So this is a simplified version. We do have lots of derived tables that's not directly from like a CDC. Yeah, and we have a whole bunch of engineers who work on like those ETL tables. We use Airflow and DBT for that. But yes.
I'm a little bit out of date on the Presto, state of Presto DB Presto.
Yeah.
I think in one of the slides you mentioned that you're running metadata, you're running metadata analysis periodically to get the query statistics.
Yeah.
Basically to speed up joins.
It's mainly speed up join. It's mainly for the memory consumption part. For example, how does it work? Like if you join table A and table B, right? If table A has like a huge cardinality, right? You don't want to build a hash table with table A. You want to build a hash table with table B because table B has like a,
I think you also mentioned that you're running it with a hosted solution.
Yeah.
How's the experience for you running Presto DB
Mm-hmm.
or like basically large join? I mean, I think not just with like across basically data sets with potentially small cardinality, like large data sets with small cardinality. Basically, like lots of nulls or things.
Yeah. You know. So that's why if you don't analyze the table, you don't know, right? So the join. So basically, the query optimizer Presto has to make a decision, like which table do we want to build a hash map on. It depends on which table you actually literally write the query, the order of the literal tables in the query, basically in the string query string. So that's bad. That's really bad. And so that's what we found out, that our memory consumption is huge. And then that's one of the benefits of working with the SaaS. We showed them this case, and they helped us to identify the issue. Actually, it's because we don't analyze the tables. So now we run analyze periodically, so we know that the cardinality of a large table is small.
One question: have you ever found there's any right bottleneck on this pipeline? For example, like TiDB is a distributed database, can the writes throughput can be scaled out very well. And I think there will be some bottleneck on the CDC and the Kafka side.
Yeah.
Have you met anything like this?
Write patterns.
Right.
Insert patterns.
Basically, the write throughput, for example.
Yeah, it's I mean, yeah, both as a business, it's quite obvious. You can see it up and down. During the day, it's super high. I think it's a few 100K transactions per second, and in the night, at 3 a.m., it's really low. Yeah, so we do have peak hours in the morning and during the day, and a much lower write throughput in the evening.
So basically, my question is about how many. For example, you have what's the ratio between the TiKV node, which is the storage node, compares to the CDC class node? Is one TiKV to one CDC node, or couples of TiKV nodes to one?
I think if we talk about, I think the way that that's another interesting question, because since we switched to TiCDC, the ownership of TiCDC is unclear. And right now it's DBAs who takes care of that. And before, data engineering was actually owner of Debezium and CDC. So we changed ownership of CDC because of the change, actually. So I think what they do, I might be wrong, is that they have the same configuration of TiCDC for all our TiDB clusters. Each TiDB cluster has its own dedicated TiCDC cluster. Yeah.
Will you help me to take a look at this?
Yeah, sure. Yeah. Yes.
What is the role of Amazon Glue? I didn't catch that.
Right. So basically, So basically, when you have data on S3, there's just data. There's no metadata. You don't know like which are the columns of the table. So what Glue does is actually it doesn't have any real data. It has metadata about the table, like list of columns, its types, and how many partitions. Those kind of like table statistics or column level or partition level statistics. They're all stored in Glue. So what Presto does is Presto would actually you give a query like query something from a table, and Presto would actually look at Glue first. It checks are the column names correct when you send this query to Presto, right? It checks it from reading tables metadata from Glue, and once it knows the metadata, so Glue actually has the file path, the location of the files on the S3. It would actually go read the files on the S3.
Okay.
Yeah.
And Presto use a different component for this?
Sorry, Presto.
Does Presto have to use Amazon Glue?
No. It's basically Hive Metastore compatible. Anything, yeah. Mm-hmm. Yeah.
I think you mentioned you use Delta Lake.
Mm-hmm.
And Delta Lake includes, it has like transaction. It offers transactions.
Yeah.
I was wondering. I'm assuming you're using Delta Lake to expose the data to Presto. Was that the goal or one of the goals?
So what's the goal?
Using Delta Lake to expose the data to Presto.
Yeah. Yes.
So I was wondering why. I was wondering what level of delivery semantic you're running your Kafka cluster. Is it like exactly months, or is it at least months? Because I don't know.
Well, Debezium has at least one semantic, so it can actually reproduce the same record. But because we run Delta Lake and we do a merge, even though Kafka receives the same role twice or 5 times, it doesn't matter, because we would actually do duplication based on what's the last version, only the last version of the same role. So it wouldn't. So we wouldn't end up with the duplicated roles. Yeah. Mm. Good. Right. Thanks.